Okay, so what we're going to look at right now is curve sketching from a graph. So how to read a derivative graph. So I'm going to show you a picture of the first derivative, and I want you to answer questions about mom, about the f of x, right? So all of these things that we describe over here, this is about f of x, right? So let's think about what we're doing. It's like I have a picture of you, and I'm going to use that picture of you to describe your parents. So I'm going to be giving you a picture of the derivative, and I want you to tell me things about the f of x graph. We'll actually even answer a couple of questions about the second derivative, all from this first graph. We're going to practice with that, okay? So what do we need to know? Well, first of all, where are the critical numbers? If I look at a derivative graph, what are the critical numbers? Those are the zeros. We're going to write this out, and then if you can do the work while looking at this paper, then I know you understand, and we'll work on some memory techniques. This year, you of course have your notes, but that may not be true next year, right? Okay, so if you look at a derivative graph, how do you know where the parent is increasing or decreasing? You can tell when the derivative is positive, and by positive, we mean it's above the x-axis. So if you look at a derivative graph and it's up above the x-axis, you know the mama graph was positive, was increasing. Now, if you know increasing, do you have to think about decreasing, or do y'all know what decreasing is? If increasing is where it's above the x-axis, what's decreasing? Where it's negative or below the x-axis. Remember what the tough part is. You're looking at a derivative picture and you're answering questions about the parent. How do I know where the parent graph has a min or max? That's going to occur where we see a 0. So where you see a 0 and it's going from positive to negative. And what we mean by that is above x-axis to below x-axis, right? So if you see a graph above the x-axis and it crosses the x-axis and then goes below, that would have been a maximum on the parent graph. So can you tell me what a minimum is now? There we go. Where you see a 0. So where you see a 0, but this time it's negative positive. It's below the x-axis and it goes above. If you see it going from underneath, crossing x and going above, then that was a minimum on the mama graph. How do I know where mama graph is concave up? The slope or the graph, right, is positive or increasing. You know, it's going up. So if I know concave up, do I know concave down? What would concave down be? Where you see what? Yes. Why did I write C? Slope of the graph, right, is negative or decreasing. Now we are looking at the first derivative. When you look at the first derivative, how can you figure out where the second derivative would equal 0? Where what you see flat or undefined or max or min, right? And what we mean by that, right, if you had this, right, here the derivative is 0, right? But if you get a flat spot right there where it's flat or undefined, the second derivative is 0. Remember, this is a picture of f1, f prime, the first derivative. So anywhere that you see a slope of 0, the second derivative is 0. This is the spot that you're not used to looking at, and we'll do some examples with those. How do I know where there's a point of inflection on the main graph? That's where you see a max or a min. Slope equals 0. Okay. You're going to see when we do one that a flat spot may not be a point of inflection because, like right here, see how this max or min, I'm going up, I get to a max, and now I'm coming down. That's where we had a point of inflection. But if I go here and I flatten out where my slope is 0, but I keep going the same way, then I didn't have a point of inflection. That's kind of like when we had the arrow and we had a plus plus or a minus minus. Okay. Now, what about the sine chart? So imagine you're looking at a picture of the derivative. So let's say we have some zeros on there, right? This is a 0. Wherever it crosses that x-axis, it's going to be positive if it's above x-axis. And you would call the sine chart negative if it was what? Below. So if you are looking at a first derivative graph and you want to make a first derivative sine chart, you're just looking at the graph, and wherever it's positive or negative, you're looking at the picture. Now, how can you make a second derivative sine chart? Let's say there's a 0. This time, your 0 is going to be a max or a min. You're going to see a max or a min, right? And it's positive if the slope is positive, and it's negative if the slope is negative. Okay? So some of this won't make sense. I want to do examples with you, but I wanted you to have some things written down. So as I talk about them, you can kind of check your chart.
Miss Coughlin, could you move the paper up a little bit?
This way?
Other way. Very bottom. Yes, ma'am. Thank you.
And then there's one other thing, but let me let y'all get this written down. This, if you look at this while we do our examples, you're going to be like, oh, this is so easy, right? The other thing I didn't put on there is if they ask you the slope at a given point, like what's the slope at 4, right? The slope is the y value. You'll see when we get to that question, but I want you to have that written down. So this kind of summarizes everything we talk about so you can focus while we do our problems and not have to be writing everything down real fast, right? Because you have it. And you have it on a piece of paper. So as you do homework, if you're in Delta Math, you're not like flipping back to class kick. You've actually got it written down here. Can you add more to this as we do problems? Of course. Anything that you think you need, write down while we do our examples, and then you got everything in a nice, concise spot. Sometimes reading a graph is kind of hard because I'm showing you a picture and I'm asking questions about someone else. Does that make sense? Sometimes I'm asking about the parent. Sometimes I'm asking about the child. Okay, is everybody caught up? Are we ready to try some? All right. If you're at home and you came in late, just snap a quick picture. Let me make it as small as I can. So if you got here late, snap a quick picture, and then later on, you can take time to make one of these on paper. This is valuable to you because everything's in one spot. Okay? All right, then. Let's get our notes out, and we're going to see if your notes helped you. Are you ready? Yes. What? Oh, just write on paper. You know, you could just label 1, 2, 3, 4, and you could see my graphs, and then you can write it down when you get home. And there's paper up there. I gave away my last set of notes last block. I did have one extra set too. All right. Now I'm going to pretend to be a kid. So as we do these, I'm going to go to my brain and say, hey, where is that? I want to make sure, because if you understand your brain, you can do it. Then you just have memory work to do. Are we ready? List the critical numbers. Now remember, here's what you have to remember, and it's easy to forget. This is a picture of the derivative. These questions are about the mama graph. Okay, all of these questions are asking about what's happening on the parent graph. This is the child, this is the derivative. So you can't just, what you see isn't what you get kind of thing. You have to know what it means. So how do I find the critical numbers? What does it say on your brain? What are they? Where you see zeros. So what are the critical numbers? -3, -1, 1, and 2. Let me get in so you can see. There we go. On what intervals is the parent graph increasing? Okay, I don't know. I'm just a kid, right? So let's look. Increasing. Where is it increasing? Oh, let's see. This is too easy now. And you know what I could do? I could do this if I want a really good visual aid later, right? So where is it increasing? -3 to -1 and 1 to 2. Explain, why is it increasing there? It's above x-axis or positive. Anything above the x-axis we call positive, below the x-axis we call negative. Okay, what values would there be a local min? How do I find a local minimum? Where's the min? Right there. Where you see a 0, that's going from below to above. Okay, where am I going from below to above? Well, you know we trace this way, right? So, oh, I'm below and then above, so right there, right? Wait, did I ask for max or did I ask for min? Okay, I'm doing mins right now, right? True? Because a min, we go from below to above. I skipped that one and went straight to that one. That's okay, I'll highlight it here. Oh, right there. Now, where are we going to have a local maximum? What's the rule for a maximum? Tell me the rule for a max. So we are above and we change to below. So here we're above, now we're below. Here we're above, now we're below. Okay? So a maximum comes from where? Above to below. This is below to above. So where is that? Orange ones, -1 and 2. Green ones. How do you feel about that? That's not bad, right? All I gotta do is look at it. Okay. For what values would the parent graph have points of inflection? How do I find a point of inflection? How do I do that? Okay. Let's explain where you see a min or a max. And I want you to focus because sometimes the way that they ask questions on different problems in calculus, it can get confusing. You've got to really know what's going on. Let me find another color here. Did I use orange or yellow? Okay, so where I see a min or a max. So where is that? Right here, right here, right here, right? So what would you call those? X equals what? What would you call this one? That's -2, that's -3, and that looks, so what do you want to call that? You're going to have to estimate. -2 point what? See how it's off? 2.2? 2.3? What do you think it is? Oops. 2.2. We have to estimate on this because it's not exactly, it's good, right? This one I think is right at 0. And this one is exactly halfway between 1 and 2, so I'm gonna call that 1.5. I'm too far in now, y'all can't see anything. There we go. Okay, where is it concave up? I don't know. How do I find that? Well, how do you know if it's concave up? Okay, it's going up, right? So show me where it's concave up. I need another color. Pink. So now it's decreasing. Does that make sense where it's concave up? So what would that be? -infinity to -2.2. It's going to be whatever you picked for that number. And 0 to 1.5.
Miss Coughlin, can you scoot it down a little bit? Thank you.
I zoomed in too far, didn't I? Let me fix that. There we go. What do you think? Is this, can you do it if you're looking at your cheat sheet brain? It's not bad, right? So I want you to be really good with that. So let me see now. I'm going to give you a test. So now I want y'all to, these are the same questions we just answered together. So I want you to use your paper brain and I want you to try these. Okay, there you go. I'm going to zoom way in for a second because a couple people don't have notes and they need to see the graph. So y'all try this. Okay, I want y'all to try to answer them using your paper brain. So pretend it's a quiz because I'm mean and cranky. Oh, that's right. You need, I got to find you one. I've got to find you one because I don't have one. You're right. You need, and mine are all scribbled on now. Let me see if I can find one. If I had a piece somewhere, I don't. Oh. Well, rats. Okay. Can you see the graph though? Kind of mark in your mind where stuff is, and then I'll zoom out. I'll make it there. Can you see that okay? Okay. We'll, of course, go over it together, but I just want you to try to see what you got, and that way you'll know where your questions are. Okay, and I'll get attendance marked off. So Ian's here. Did we ever, Grant and Karsten? Grant or Karsten, are you in there? Did I, oh, Karsten, there you are. Oh, wait, no, I've got you. Well, Inkiad and Burke for sure aren't here, but online I'm just missing. Grant, are you in there and I'm not seeing you? Grant? Okay. I'm gonna put attendance in while y'all take your pretend test. Oh my God. No. Yes, I hit the wrong one. All right, let's put up the answers and let's see if you got them correct. If there's any that you're like, wait, I didn't get that, please feel free to ask, why did you do that? So check your work. The rest of this block during notes, we're going to be doing a lot of you try it. Now let's check it, you try it, until we get to the last one, which has a couple weird characteristics on it. Did you get them? How'd we do? Good. Okay. And I thought as a kid, I thought question number 1 was hard. When I looked at that, I was like, the slope of the parent, how am I supposed to know that? But what does slope mean? Derivative. So if you look at -2, the answer is 6. So that tells you the slope. That connection I thought was kind of hard to first see as a kid. You know, it was hard if I can remember back to thinking it was hard, right? Because I've been out of school for more than 5 years. Okay, are we ready to try some more, to look at some more examples together?
Ms. Coughlin,
Yeah.
how did like can you show me how do you do the min and the max?
Wherever it's below the axis, then it's above. So if you're moving your pencil right here, you're below X, and now you're above X. So
Okay.
it's going to be a max.
Okay. All right. All right. Thanks.
Or a minimum. Now a maximum, we're going above to below. So right here, I'm above the x-axis. Now I'm below the x-axis. So right there is going to be a minimum max. Does that make sense?
Thank you.
Okay. And y'all, as we go, if anything makes you realize, oh, that's what that means, write it down on your brain. Have one nice, concise place to put everything, right? Okay. We're going to try another one. I added a couple more things to the next example. And we may not have to do this entire example. We may just do the sine charts because we haven't done a sine chart from a graph yet. So how do I do a sine chart? If it says, what is the first derivative sine chart for this graph? Well, this is the first derivative. So all I have to do is actually look at the graph, right? So where are the zeros? -3, 2, and 6, right? Now, right here, I'm going to use colors. What would you say about the orange parts? What are the orange parts? Positive or negative? Negative, because they're below. What are the purple parts? Well, there you go. So what order does this go? Negative, positive, negative, positive. And make yourself a note. Above X, below X, axis. I'm just not writing. Above, below, right? So not hard to make a sine chart, right? Now, what about the second derivative sine chart? I want to for sure do that with you. What goes on my second derivative sine chart? Let's look at your brain. Look at your brain, and what do I need to write down? The maxes or the mins. So where do you see a max? This is -2 right there. So where do you see a max? Well, -1, right? The max is right there. And where's the minimum? About right there. What is that? 4.3? 4.2? What number do you want to pick? Okay, and then how do I read it? Wherever the slope is positive, it's positive. So right here, let's put that in yellow. So right here and right here, what kind of slope do we have? It's a positive slope, right? And then of course, that slope in between is negative, right? Put that down for you guys. Okay, so those were the two new things. So you
Miss
take a second. Yeah.
For number 5 for the second derivative, when you look in between -1 and 4.2,
Yes.
is
Huh?
it just it's negative because it's just decreasing?
It's going down.
Okay, thanks.
All right, so now the other questions are ones you've already answered, so y'all try to fill those in. Go. Today is all about you practicing, so y'all try to do the other ones now. Mark it, set, go. And look at your paper brain. Make sure that it's good for you. Okay, I think we're ready to check. So here's what we got. Make sure that you are getting all the numbers. So check your work. We're taking like 5 little mini quizzes to keep checking, and every time you get something, we know you're good, and we'll address the ones that are still feel hard. Is it pretty good? Are you comfortable with, if you have the paper brain, you're like, oh, this is so easy, right? Okay. Everybody get a chance to check? Can I move it? Yes, sir. The POI is where you see a min or a max and it changes, like going up, then coming down. All right. All right, how do we feel? Is this easy or hard? because it's one
Ms.
of the two,
Kaufman?
there's no middle of the road. Yes, ma'am?
Just for the minimums and maximums, like whenever you're like looking at those, are you kind of just like looking at where they touch the
Remember,
x-axis and go from
a
negative?
minimum is negative to positive. This is positive to negative, so it's where you see a 0. Okay, so make sure you write that on your chart. A min or a max occur where you see a 0.
Mhm.
A maximum is when you're above the axis and then below. So like as I go this way, I'm below, now I'm above. So what is that? Below to above is a minimum.
Okay.
Here I'm up above the x-axis, I cross and I'm below. So if I go from above to below, that's a maximum. And then I'm over here and I'm below to above, so that's a minimum.
Okay. Thank you.
You're welcome. So I'm not going to do number 16. We'll wait and come back and do that if we need it, because I'm going to do 17 with you, which is a little bit harder. So we're going to go through this one together and see if you're an expert yet. So we'll talk our way through. What's different about this one? What did I throw at you this time? This little thing, this little flat spot, right? So if you're looking at this, the numbers are a little bit hard to read. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's -1, right? -2, 3, 4, 5, 6, 7, 8. Okay, so you may have to kind of mark your paper up. Those just aren't as clear, but let's see. But I did get it smaller so I can make it bigger. Let's see if we can answer everything about this crazy little guy together. This is our last one, so we kind of wrap up what we're doing, right? So where is mammograph increasing? How do you know where it's increasing again? Okay, let's write that down. Above, that's what justify means. Means tell me why. So above x axis. So where is this thing above the x-axis? And you can color it, right? So if you're a color coding person, I definitely am. I can do that, right? Okay, so where is that? That's -8 to -1. And I want to point something out. When you guys see a graph where it flattens out, a graph isn't exactly flat there, but it gets extremely close, but it crosses at one point. It just looks like it's on the graph for more than one point because of the limitations of ink, because that space is so tiny, right? It's infinitely small. Okay, then where is the graph decreasing? What words would you use for decreasing? Below. Is it good for you to keep writing this down? I keep writing the same thing down. Yes, because this is kind of hard stuff. So I'm color coding. So later on tonight, when I look at this by myself, I can say, oh yeah. So that's what? -9 to -8, right? Right over here. And -1 to 9. We're used to writing infinity, and this graph actually has open circles on the end, if you can see it. It did not print that well. Okay, where is the max on the mammograph? How do I know that? Yes. And what does a minimum do? Zeros, right? So we find the zeros and we see which way they're going. So this 0 right here, what does it do? Below to above? So what happens at -8? At -8, mama has a min. Then we go over here, and right there at 1, we were above and now we're below. So what was at 1? Max. on the mama graph. -1, not 1. It's a -1. Okay. Now, do I cross anymore? I don't cross this graph anymore, do I? No. So that's it. That's all I got. Where is mama graph concave up? How do I know where it's concave up? Positive slope. Or graph increasing, however you want to think about that. So let me get a concave up, right? Increasing. There's where it's increasing. Now, where is it decreasing? Or concave down, sorry. Negative slope or graph is decreasing. Where do you see a negative slope? Well, does that make sense with the color coding? Is it easy for you to look at that? All right. Now tell me where that is. So how do we write that orange part down? -9 to -4. And what is that? 4 to 7. And where do we have a negative slope? That's my blue part, right? So the blue part is -4 to 4. And that's 7 to 9. Does it help your eye with the different colors? Okay. Where does f prime prime, that means where does the second derivative equal 0? Well, this is a derivative, so if we look at its derivative, that's the second derivative. So this would be slope equals 0. So that's maxes, mins, or flat. Where do you see a max, a min, or a flat? -4, -1, right? Uh, 4 and 7. So the second derivative is 0, right? I'm going to put those with red dots. I want to make sure you're seeing what I'm seeing, right? Wherever that's 0 or a flat spot. Because think about it, this is a derivative curve. So if you look at a slope at any given point, you're looking at the second derivative, right? True? That's true. Okay. Where is there a point of inflection? How do I find one of those? But C max or min, but not just a flat spot, right? Because if you look here, this is negative, flat, negative. So that's not going to be a POI. These are positive, negative, negative, positive, positive, negative. So they change direction. So where you see a max or a min. So this is going to be what? -4, 4, or 7, right? What do you think with this little nice problem where it's all done with a picture and with your brain? Do you have the resources to do these? Yes. One last thing. This is just a picture for notes. Let's do a sine chart. So what's going to go on the first derivative sine chart? Since it wants the first derivative sines and this is the first derivative, you just read what's there, right? So it's going to be what? -8, -1, and 7. And before -8, the graph is under. So that's negative. Now here it's above, positive. -1 to 7 is negative. And then it's still negative. Right? We didn't change sign right there because it's below and below. Remember, this negative means below x-axis. Positive means above. All right, the hard part is the second derivative sine chart. What goes on that? What do I put for my little points? Maxes and mins. Excellent work. So what's going to go there? -4, negative, and flat spots, right? Because it zeroes out. These are the zeros where slope is 0. So those are maxes, mins, or flat spots. Now, how do I know? To get my signs, what do I read? Slope. Because it's the second derivative, which means it's the derivative of the derivative, and derivative means slope. So right here, we're positive, then we're negative, and then negative again, and then we're positive, and then we're negative. Now, does your sign chart match down what you wrote? Well, if I change from plus to minus, I should have a point of inflection. So according to this, you should have 1, 2, 3 POIs. Did you get 3 POIs? Yeah, you did, right? This helps you to visualize why -1 is not a point of inflection, because we were negative and we're still negative. Okay. You guys are now certified experts.